I have a problem, and that's water. I don't drink enough of it. In fact, I spend all my time playing Helldivers and I forget. I'll go an entire day and realise that I've had like vibes, nothing else. My body sends signals and I ignore all of them. I could fix it with reminders or notifications, maybe even alarms. But instead, we're going to do this the Pavlovian way. We're going to use punishment. I get punished every time I don't drink water. Let's make a plan. We'll start with what we know. I have a cup full of water and it needs to be drank. My first reaction is to put a moisture sensor inside of the cup that then detects the water level. Depending on the level, it would send a signal away to a microcontroller that then decides, hey, this is fine, or maybe we need to give the user a little bit of a push. And by push, I mean an electric shock. My first reaction for punishment is to go to a dog shock collar, and it'll give me a nice helpful job to make sure that I'm staying hydrated. I got my dog shock collar here. Look, so happy. Can't be that bad. This is the collar part, which, yep. And then there's the shocking one. Shocking. What's this? Vibrate, and that's annoying. Beeps. Cool. Nice. Let's give that a go. Shock collar test 1. Okay, that could be good, actually. I'm gonna have to use something different. This time, let's not alter the cup. Let's say that the cup's on a platform, a coaster. Why don't we just make noise? We'll take an example from the dog shock collar and actually use beeps. That's enough to annoy and distract. Instead of using any sort of signals or lasers, why don't we just use the weight of the cup? We know that it's full when it's got a lot of weight. We know that it's empty when it's got very little weight. It's good enough. I mean, we're building a glorified scale. Oh no, we're building a scale. So, here's what you need. A C3 Super Mini, an OLED display, a buzzer, RGB module, HX711, load cells, and everything they come with, a breadboard, solder, soldering iron, and that's it. I can tell you're thinking, how does a scale work? And it's all to do with these load cells. Each cell contains 2 excitation wires and a signal wire between them. Think of each sensor as a piece of metal that gets sad when you stress it. Not emotionally sad, physically sad. When metal is stretched or squished, it doesn't like it, and its electrical resistance changes. That changes metal sadness. And we don't just use one sad piece of metal, we use 4. They're wired so the circuit doesn't ask, how sad are you? It asks, who's sadder than who? When nothing is touching it, all 4 pieces of metal feel exactly the same amount of sadness. Life is fine, because their sadness is equal and the bridge is balanced. The output is 0. But when you add weight, now you apply force. 2 pieces get compressed, their sadness go up. 2 pieces get stretched, their sadness changes in the opposite way. Now the sadness is uneven. The bridge detects the emotional imbalance and turns it into a voltage. More imbalance equals more voltage. We use 4 sensors because metal is always a little sad, due to temperature changes, aging, or electrical noise. Those things make all of them sad at the same time. But the Wheatstone bridge ignores shared sadness, and it only reacts when it knows a force is happening. To check which wires are your excitation wires and your signal wire, you can do this by measuring the resistance between pairs of wires. If you see 2K between 2 wires, you know that those are the outer, and 1K between, while you're looking at ones that are directly next to each other. You can then pair the ends of the wires together with the signal going towards the HX711 amplifier. Let's get prototyping, so get out your breadboard and follow along. Start by placing your components. So I'll bring you in closer. Okay. Attach the ESP's ground and 3.3 volts to the power rail. Do the same for each of our components, bearing in mind that your voltage in could be denoted by VCC, V in, or a plus. Your ground may have G, GND, or a minus. And it should look a little something like this. So now for the good stuff. Locate your HX711 and place a line from data to GPIO4. The data pin is denoted by DT on the board. If you're a visual learner, GPIO4 is right here. Finally, you want to run a line from the serial clock to GPIO 5. The serial clock's pin is denoted as SCK. GPIO 5 would usually be next to GPIO 4, but in this case it's on the other side. You may notice that I actually put this in the wrong spot. I redeemed this later, so make sure you validate before putting something in. You then want to run the OLED's serial clock to GPIO 7 and serial data to GPIO 6. And with that completed, it should look like this. And as always with these videos, something went wrong. About now is when I realised that this is broken. I'll show you. So, if we take this, plug this bad boy in, here's a minimum sketch. If you ever have any issues, I recommend you do a minimal sketch. Look, blue is red, green is red, red is non-functional whatsoever. Okay. But no worries, after a quick replacement, everything appeared good. It's not easy to put it anywhere. Oh wow, look at all those colours. To attach this up, we set our ground to the shared ground. We then put the R to GPIO 8, the G to GPIO 9, and the B to GPIO 10. Then everything should work. I should see is green, white, white. Remember, if you upload a test sketch, change it back, or else you might get as confused as I was. Purple. Ground. I think that's 8, 9, 10. Onto the buzzer, run a line from shared ground to the minus symbol, and then run a signal into GPIO 3. And now you can run a few tests. If you're happy with the test, you're ready to move on to the next step. I just need to put this in a place that... Oh, okay. So that works. That is very, very annoying. Okay. Well, we can start thinking about actually packaging it together. Ah! I designed the body in FreeCAD, as always, and you can download the project files from the GitHub. It consists of a front, a base, and a top part. It's nothing too crazy, but everything should fit relatively snugly. All you have to do is print it off and assemble. And the slot clearance is grab your HX 711 and then place it on the guide posts in the center. Grab your load sensors and clip them into the allocated slots. Once they're soldered together, they should look like this. To secure the wires down, we turn to our trusty glue gun. Just remember, hot glue isn't conductive, so use as much as you want. After every step, I like to take out my multimeter just to make sure that I haven't created any shorts in the system. Moving on, take out your front plate. Okay, so we have this piece now. You can see it's got the notch there. Using the cutouts, you can actually align the LCD quite snugly. So once you have it nice and aligned, take out your glue gun. Yes. Use as much hot glue as you need to secure it in. After the screen is nice and secure, take out your LED. Align this next to the LCD and then take out your glue gun. Take out your glue gun. Now it's time to do the same to the other side with the buzzer. Yes, glue. Now, you should have two pieces, a front and a base. The ESP-C3 slots perfectly into the slot at the back here. So once you've soldered all the lines to the GPIO, that's where it lives. The front panel easily slots into the base like so. So when that's all soldered to the ESP, that's how you assemble. And there you have it, a solution to hydration. I'm quite happy at its low profile and how it looks. It could be a coaster. All you have to do is plug it in and then load up your favourite drink on top. It'll detect the base level, and anything less than that, it'll consider you having drank. It also keeps track of how much water you've drank relative to what your daily intake needs to be, so you know that you could always be hitting your goals every session. It's also worth noting that this lip actually serves as a drip tray, so if you end up spilling some of your liquid down the slot, it actually will funnel smoothly over the electronics, destroying it. Fantastic, it's a feature, not a bug. Anyway, apologies if this is scrambled. Somehow I ended up losing a bunch of footage and I had to just do the best that I could. So as long as you can understand it and you can build it, that's great. If not, let me know in comments or on Instructables. I do reply to them and I think there's a lot of improvement to be made. So yeah, anyway, till next time, see ya.